Welcome to 4.4, Division with Fractions. This section we're going to focus on division, but we're going to kind of put together the order of operations in its entirety as well, because then we'll have some of the other properties like multiplication that we did last time. So the first thing we need to talk about is the idea of a reciprocal. Two numbers whose product is 1 are said to be reciprocals. So when you multiply, let's say you have a over b. If you multiply that times b over a, then you get ab over ab, which is 1. Right? In other words, they cancel out in the sense that they reduce to 1. And so these numbers are said to be reciprocals. Let's look at some examples here so you can see a concrete illustration. Here's 3/4. Its reciprocal is 4/3. All we have to do to find the reciprocal of a number is to flip it. Right? If it's a fraction, we flip it. If it's a whole number, we have to put it over 1 and then flip it. And its reciprocal is 4/3 because if you were to multiply 3/4 times 4/3, you'd multiply straight across, so that'd be 3 times 4 over 4 times 3, which would be 12 over 12, and 12 divided by 12 is 1. And so whenever you flip a fraction, whenever you invert a fraction and multiply it by the original fraction, you will always get 1, right? If you multiply a number by its reciprocal, you'll get 1. And this is going to come in handy for us. So let's look at some other examples here. The reciprocal of 9/5 here is 5/9. The reciprocal of 1/3. So if I flip 1/3, that would be 3 over 1, right? Now when I multiply it, it is helpful for me to write 3 over 1 so that I know that the 3 is a numerator. But when I flip the 1 over 3, I can just write it as a 3, right? I don't need to write 3 over 1 if I'm just naming the reciprocal. Now, obviously, when I go and do the arithmetic, it's helpful to put the 3 over 1 so I know it's a numerator, but you'll see it in both ways. So then, what if you want to reciprocate 7? What's the reciprocal of 7? Well, first, in your mind, put 7 over 1, then reciprocate. Invert it, flip it. All right, 7 times 1 is 7, 1 times 7 is 7, 7 divided by 7 is 1. So they are reciprocals. So that's what a reciprocal is. And that's going to come in pretty handy for us. Now, one of the reasons why it comes in handy is because division with fractions isn't very easy. It's not very intuitive. So let's look at an example before we do anything. How about I have something like 2, and let's do it like this. Let's write it numerically. 2 divided by 1/4. 2 divided by 1/4. It's not a very intuitive problem to think about. So here's how we can visualize it. I can start with however much I have with the first number. In this case, 2, I have 2 wholes. And then I want to divide it, I'm going to cut it up into quarters. So let's see how many quarters there are. So if I divide this into quarters and this into quarters, there's 1, 2, 3, 4, 5, 6, 7, 8 quarters. So I think that 2 divided by 1/4 is 8. Now that's great if I can visualize it every time. But how could I show that mathematically? Well, it turns out that the relationship here is that when you're dividing by a fraction, let me draw the original again. When you're dividing by a fraction, that is the same as multiplying by its reciprocal. So dividing by a fraction is the same as multiplying by the reciprocal. So instead of dividing 2 by 1/4, I can multiply 2 by 4/1, and of course the 4/1, the 1 I don't really need, it's 2 times 4, so 2 times 4 is 8. And that's what I predicted it was going to be before by visually inspecting it. Now I know that this works every time. Another way to think about it, $2 divided into quarters, right, which is 25 cents. So $2 divided into quarters, that would be 8 quarters. And so there's lots of ways to think about it, but the pattern is that whenever you're dividing by a fraction, you can multiply by its reciprocal instead. So let's look at this example here, 1/2 divided by 1/4. So if you had a half, how many quarters would go in there? It looks like 1, 2. So I'm thinking the answer here is 2. Now that's my preview. I'm going to preview that I think there's 2 quarters in a half. Now let's do the math here. So what I'm going to do is, instead of dividing by a quarter, I'm going to multiply by its reciprocal. Then when I multiply fractions, I multiply straight across. And then always reduce whenever possible. 4 divided by 2 is 2. And that happens to be what I predicted it would be. Okay, so that's the pattern. And now we can cruise right along and look at some examples and see what kinds of sticking points come up. So here's one. 2 divided by -1/3. Well, a positive divided by a negative is a negative. So I already know that the answer is going to be negative. And in the case of 2, if I take my 2 wholes, and I split it into thirds, how many? That's 1, 2, 3, 4, 5, 6 thirds. So -6 is my prediction here. Now, what does the algorithm say? The algorithm says instead of dividing by 1/3, you can multiply by its reciprocal. The reciprocal of -1/3 is -3. 2 times -3 is -6. So you can get there visually, you can get there numerically, and I really recommend you practice this multiplying by the reciprocal, because it's going to come in handy. Now, why was the reciprocal of -1/3 still -3? Because remember, when you multiply 2 numbers, they are reciprocals if they multiply to +1. Well, a negative times a negative is a positive, and 1/3 of 3 is 1. And so if your number is positive, then your reciprocal is positive. And if your number is negative, your reciprocal is negative, because the signs have to be the same so that the product is positive. Okay, let's keep looking at some examples here. Now, whenever we divide fractions, right, we're going to do this. We won't actually be able to divide them. Instead, we will have to multiply by the reciprocal. So we'll copy the first problem, or the first term down how we see it, and then we will change division to multiplication and reciprocate the second fraction. So it's 9/16. Okay? And I'm multiplying instead of dividing. now I have a couple of choices to make. I can try to factor these numbers, right? I could just multiply straight across and then reduce later, but what I'm going to try to do instead is I'm going to try to reduce as we go. So I know a negative times a positive is a negative. I've got 4 times 9 on the top. 27 could be 3 times 9. And then 16 could be 4 times 4. And this helps me to see that 9 divided by 9 is 1, and 4 divided by 4 is 1. So that's negative. And I have a 1 on top, because when everything cancels, there's still a 1 on top. And I have 3 times 4 on the bottom, so 3 times 4 is 12. So negative 1/12. So it's a little counterintuitive, but 16/9 divides into negative 4/27, negative 1/12 of a time. So you can see, because it's not very intuitive, that's why we really need that procedure of being able to multiply by the reciprocal for when it's hard to visualize and the numbers don't make a lot of intuitive sense. So now we can put together some of the properties of the order of operations. So let's have a look here. So we've got 32 divided by 4/3 squared plus 75 divided by 5/2 squared. Now the order of operations still stands. None of that has changed. We do what's inside parentheses, if there is anything to do inside parentheses, which there isn't here. Then we go on to evaluating exponents, so that's the next thing to do. So I'm going to want to expand this 4/3 here. So 4/3 squared is 4/3 times 4/3, which is 16/9. So this is 32 divided by 16/9 plus 75 divided by, now I'm going to square 5/2. So that's 5/2 times 5/2, so that's 25/4. Now that I've evaluated exponents, I can move on to multiplication and division. I see there is some division here. There's some division in 2 different places. So I'm going to go left to right. Now when I divide by a fraction, instead of actually dividing by a fraction, I multiply by the reciprocal. So this is going to be 32 times 9/16 plus 75. And I can go ahead and I can reciprocate this and turn this into multiplication by its reciprocal as well. Now I'll do some of the math here. This is really over 1. 16 and 32, they have a 16 in common. 16 goes into 16 once and into 32 2 times. And 2 times 9 is 18. And if I put 75 over 1, I see, 25 goes into 25 once and into 75 3 times. And 3 times 4 is 12. And it's all over 1, so I don't need to write that. And 18 plus 12 is 30. All right, here's a translation problem. And then once it's a translation problem, it's an arithmetic problem. So it's the quotient. So we know quotient's division. The quotient of 8/3 and 1/6. So the quotient of these two numbers is increased by 5. What number results? So this is the quotient. This is the quotient of this and that, then added to 5. So let's go ahead and figure this out. Now I can't divide fractions, really. So instead I multiply by the reciprocal. Now the first fraction stays the same. So this is where the idea of copy comes from. We copy, we dot, we turn this into a dot for multiplication instead of division. And then we flip the second fraction. We reciprocate it. Now here I'll just go straight across. Oh, except that I see 3 goes into 3 once and into 6 twice, so I can reduce there. And 8 times 2 is 16. And 16 and 5 is 21. Now in this case, everything's reducing very nicely to have denominators of 1, which means it's a whole number, so I don't need to write it. But that won't always happen, right? So we'll see later on that sometimes we're stuck with fractions. So let's review. What do we call two numbers whose product is 1? Those numbers are reciprocals. B. True or false? The quotient of 3/5 and 3/8 is the same as the product of 3/5 and 8/3. True. Right? You can, instead of dividing by a fraction, you can multiply by its reciprocal. C. How are multiplication and division of fractions related? Oh, well, instead of dividing, so you can divide or multiply by its reciprocal. So you can either divide or you can multiply by its reciprocal. That's how multiplication and division of fractions are related. D. Dividing by 19/9 is the same as multiplying by what number? Well, dividing by 19/9 is the same as multiplying by its reciprocal. Same as multiplying by its reciprocal. So hopefully that was clear and answered some questions. And if you got new ones, let me know and we'll go over them. And I will see you in the next section.